All right, welcome to chapter 5. And I'm coming from my home, obviously, as you know, in Manhattan Beach. But I don't think I've ever asked you guys to find some fun, interesting facts about my hometown, or, well, my current hometown. It's not where I grew up. I grew up in Pacific Palisades. But um, so I'll tell you what, here's the deal. If you can find an interesting fact, a very interesting fact about Manhattan Beach that I did not previously know, then I will give you an extra assignment credit point. Um, so go ahead and give that one a shot. I mean, I know a lot about this town, so you might have to come up with something, pretty obscure or I guess exotic, for lack of another word. But go ahead and see if you can do that, and we'll see what you come up with. All right, so let's go ahead and start chapter 5 with 5.1. And you can see we're going to be getting into a new topic, something called a system of equation, or a system of equations. And we're going to learn how to solve them in this section by graphing. Okay, so there'll be a little tune later on that you'll get in doing this, but it's the first of 3 methods that we're going to learn. The other 2 will come later in this chapter. All right, but let's go ahead and just warm up. So go ahead and do these 2 problems. The directions say, tell whether the ordered pair is a solution to the equation. So I'm sure you know what to do. You're going to plug in the x value for x coordinate for x and the y coordinate for y. And if the 2 sides balance and we go check, check, then you know it was a solution. So try those. Okay, so hopefully when you plug those in, you got 4 equals 4. And yes, obviously that would mean it's true, right? It's a true equation. So that is a solution. So, oh, this one, no dice. No, 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 no. So 3-2 would not be on the graph of the equation x plus 6y equals 13. Because remember, every point, and there's infinite number of points on a line, every single one of those points, if you plug it into the equation for that line, it will make it true. Okay, so if 3 comma 2 did not make that equation true, then it's not on that line. Okay. All right, try for the next 2, write an equation in point slope form. Remember what that is. In other words, we're giving you an easy pass here. You don't have to convert it or move it to slope intercept form. Point slope form of the line that passes through the given point and has a given slope. So go ahead and practice those. So obviously you were given the slope and the point. Wow, that was nice to go ahead and do. It looks like I kind of simplified on the right side. If you put 1 parentheses x minus 1 and parentheses, that would be fine too. I just simplified it. And then here, if you put y minus -5, instead of just simplifying it to y plus 5, that's fine. But this side is what you should have had there. Okay, great. Let's move on. Again, our learning target is how to recognize a system of linear equations and then to solve them by the first of 3 methods, which is graphing. Okay, so pretend your family owns a bed and breakfast. You guys know what a bed and breakfast is? It's like if you kind of made one of the rooms where you live into like a hotel or a motel. Um, but you also provide breakfast. So, and usually they're kind of cozy and they're quiet and there's not as many rooms. It's not like a big bustling hotel or something like that. So let's say you open a bed and breakfast. It just has one room, okay? And your family spends $600 preparing the bedroom to rent. So maybe you had to, redo a window and upgrade the faucet. Who knows? Do a good cleaning job of it. Okay, whatever. New sheets, that kind of thing. And the cost to your family for food and utilities is $15 per night. So basically, when someone comes in, you got to wash their sheets and you got to provide them with breakfast. It costs $15. Okay. But your family charges $75 per night to rent the bedroom, right? It makes sense that it would be 75. It's a number more than $15, right? Because you want to make a profit. So they're charging 75. Okay. All right, so A says write an equation that represents the costs, okay? And here's kind of it written in words, and I really like how they do that in this section. So our cost C in dollars is equal to $15 per night, right, that we have to spend for the utilities, times the number of nights, plus the $600 that we had to put into getting the room ready, right? And that's a one-time thing. We only had to buy sheets once, at least initially, maybe a few years from now, you have to buy more. So what would your equation be? Hopefully you said it would be C equals 15x, $15 per night. So 15x plus 600. Okay. Now, what about the revenue or the income, the money that you're taking in? The revenue would be what? We were taking in 75 bucks per night. So hopefully you wrote R equals 75x. Okay. All right. So C, a set of two or more linear equations is called a system of linear equations. Okay. So let's write this system of linear equations for this problem. Okay. So I just basically transferred those down there. Okay, let's go to the next page. And you can, again, work with your friends, whether they're imaginary or not. And you're going to use the cost and revenue equations from exploration 1, that was back here, this one, to determine how many nights your family needs to rent the bedroom before recovering the cost of preparing the bedroom. In other words, when do you not only get that $600 back, but it's your break-even point, okay? So let's look at this. First off, we're gonna list the number of nights down, okay? If you haven't rented it out, what's your cost? Wouldn't it just be the $600 that you put into it? Right? Because you haven't had to spend $15 for utilities or anything like that. And if you haven't rented it at all for any nights, what's your revenue? How much money have you taken in? Hopefully you said 0, okay? What about if you did one night? Okay, so you not only spent the 600 to get it ready, but then you also had to spend the $15 for utilities and the food and stuff like that. But what would your revenue be if you rented it for one night? And remember, the revenue for one night is 75 times 1, right? 75. Good. All right. Keep going with this table and stop when you get to the break-even point. All right. So pause the video and do that. All right. So hopefully, as you went, these two numbers are going to get closer and closer together. Notice, because this one's only going up by 15. This one's going up by 75. And eventually, as you keep going here, you're going to break even right there. So after 10 nights, you break even. What happens after that? Well, then that's what you really want, right? You want your revenue to be more than your cost. That means you're rolling in the dough, right? You're bringing the money in every single night. You are making how much? What's your profit per night at that point? Yeah, hopefully you said $60, right? 60 bucks every night. How cool is that? Little extra income for your family. Nice. Okay. Now, here's what I want you to do. Here's those same the cost equation, the revenue equation. I want you to graph these. Okay. Now, this is a real life situation. Are we going to go outside the first quadrant? No. So go ahead and graph them. So use your y-intercept. And I know it's kind of hard because you've got to go, your slope is 15. And, from 600, it's kind of weird to do it like that. I understand that, but hopefully you had that. And your revenue, remember, this is like +0, would be down here, right? All right, so when we graph these, check out the intersection of the two lines. That's right over here. How many days? 10. What's our revenue here? Looks like a little less than 800. 750, right? Between the 800 and the 700 bar, right? Does that make sense? Yeah, because this is a representation of how much money you're taking in, okay? All right, so yeah, we just kind of did that, right? So there's our point of intersection, 10, 750, and that's the point where they cross. And we just said that was basically the same, right? That's your break-even point, okay? All right. I love this section because it really is kind of getting into kind of more real life stuff. All right. Okay, so here we go. A system of linear equations is a set of two or more linear equations in the same variables. In other words, they're using the same or multiple variables, but they're the same ones, okay? So here's an example, x plus y equals 7. You could call that equation 1 if you wanted to. And the second equation is 2x minus 3y equals negative 11. Like I said, we're going to learn 3 ways how to solve those in a little bit, or we'll learn the first one in a little bit. Okay, so what's a solution to a system of linear equations? It's an ordered pair, remember x comma y, so 2 variables, that is the solution of each equation in the system. So I want to go back to this graph. And remember, every single point that's on this line, this ray, is a solution to y equals 75x. And every ordered pair for every point that is on this ray is a solution to y equals 15x plus 600. So again, where's the only point that's on both graphs? It's at their intersection, right? And we said the ordered pair for that is 10, 750, okay? That would be the solution to this system, because 10 comma 750 not only makes one of the equations true, not only makes the other equation true, it makes both of the equations true, okay? All right, so down here, if we're going to tell whether the ordered pair is the solution of the system of linear equations, aren't we just going to plug 2 comma 5 in for x and y and make sure it makes both equations true? Yeah. So let's go ahead and do one of those. So if we plugged 2 in for x and 5 for y to the first equation, we get 2 plus 5 is 7. Does 7 equal 7? Yes. Oh, great. It makes that one true. Okay. What about the next one? Well, again, we plug in. So we plug in a 2 for x. So 2 times 2 minus 3 times 5, and then equals negative 11. Simplify the left side. Do your multiplications first, and then combine your like terms, and we get negative 11 equals negative 11. So is 2 comma 5 a solution to this system? You betcha. Okay, so go ahead and try the second one. All right, so when you plugged in negative 2 for x and 0 for y, you got 0 equals 0. Great, that makes the first one true. And when we plug in over here, it does not make the second one true. Ooh, that should be a negative there, shouldn't it? No, it should be positive. Excuse me. Negative 2 plus 4 is positive 2. Well, even if it was negative 2, it's still not equal to 0. So is negative 2 comma 0, is that a solution to the system? No. Is it a solution to the first equation? Yes. But it's not it's not a solution to both, and it has to be both to be a solution to the system. Okay. All right. So more practice with this. So give these a shot and pause the video and then come back. Okay, so hopefully you saw that it worked for the first one and it did not work for the second one, because we would get what? Negative 5, and that is not equal to 5. So that was nope. And on the second one, plugged in, it worked for the first equation. Oh, and it worked for the second. So this one would be yes. So 1 comma 4 is a solution there. Okay, so now we're going to get into actually solving a system by graphing. Before, they just kind of ask, is that a system? Now we're actually going to find it, okay? But we've also just seen how we could check our answer to make sure it works, didn't we? Okay, so step 1, you're going to graph each equation in the same coordinate plane. Okay, you're going to, instead of just graphing 1, you're going to graph 2, or maybe it's 3, but usually it's 2. Okay, step 2 is you're going to estimate your point of intersection. You're going to see where they cross. And then step 3 is to check the point that you got where they intersect and substituting the ordered pair for that in for x and y, right? That's it. Simple as that. But I've got a great tune to help you remember this. You know the tune to Three Blind Mice? 3 blind mice, see where they run. And I don't remember the rest of it, but 3 blind mice, see where they run. Well, here's how we do this. Graph each line, see where they cross. The intersection is the solution. The intersection is the solution. Graph both lines, see where they cross. Wasn't that wonderful? I know you're giving me a standing O right now. All right, so let's try one of these. So, oh, and by the way, I know you've learned different ways of graphing linear equations, right? We've learned that you could set up a t-table, you could use intercept method. Remember where you figure out what the x-intercept is by setting y equal to 0, and then you figure out the x-intercept by setting x equal to 0. And we've also learned that we can use y equals mx plus b, right? I don't care now that you've learned all three. I don't care which one you use. I want you to hopefully use the one that's most efficient, okay? And most accurate for you, all right? So all I know is looking at these two equations, I recognize they're in a certain form. That's a very handy form for graphing. Yes, they're in slope-intercept form, y equals mx plus b. So we know how to graph those. So why don't you go ahead and try and graph those? Remember, go to the y-intercept on the first one, go to 5, and then your slope's -2/1. So you could drop 2, go to the right one, or from 0, 5, go up 2 and to the left one. And then do the same thing with the second one with that y-intercept of -1. And okay, so go ahead and do that in graph, and then I'm going to uncover now. Hopefully you got that. Okay. Where do they intersect? Looks to me like it's 1, 3. Okay. So we're going to now plug in 1 for x and 3 to y to both of the equations and see if it works for both of the equations. And you can see that they do. Okay, so the solution to this system is 1, 3. Now, what do you think maybe one of the downsides to, well, there's a number of downsides to solving systems by graphing. What do you think they are? One, if you're doing this by hand, oh boy, it's real easy to have a line that's just slightly off. I mean, think about it. What if, like on this one, I just hadn't drawn this line exactly perfect and I, just done it like right there. Right? Let's say I had done that, and always, we always know to put arrows on our lines because that indicates they go on forever. Notice that point of intersection right there is way different than that one, right? And I guarantee you, that's not right. So you got to be careful. So one, it's hard to be very accurate with it. Two, it's time consuming. It takes a long time to do these graphs and then see where they cross and then plug them both in, okay? So I recognize that. You're going to like the next two methods better. Do you still have to know how to do it by graphing? Absolutely. Okay. All right, so go ahead and try this one. Now, notice these are not in slope-intercept form, so maybe you want to use one of the other ways for graphing. But anyway, you choose, you graph. Go for it. All right, so on the first one here, what I did was I just went ahead and put in a slope-intercept. One easy step, subtract 2x from both sides, y equals mx plus b. And for the blue one, looks like I probably did the same thing. I did. Okay. Did I have to? No. So when I went and graphed, you can see the red one here. And keep in mind, I've done this on Desmos, and yes, there should be arrows on these lines, but when I take a snapshot of it, they don't put them on. And so just know that they go on forever, obviously, you know that. Okay, so what does it look like our point of intersection is? Looks like it's at 1, 2, 1, so 2, 1. Okay, so let's check. If I plug in, go back to your original, okay? 2 times 2 is 4, plus 1 is 5. 5 equals 5, okay? It works for the red one. If I plug in 2 for x here, 3 times 2 is 6. -2 times 1 is -2. 6 minus 2, or 6 combined with -2, is 4. It checks. Check, check. All right. Okay, so go ahead and try this one. All right, I did these both. They're both in, slope-intercept form, so real easy to use my intercepts. So for the green one, I went to 0, 3, and then I have a graph, or a slope, excuse me, of 0.5, which is like 1/2, right? So I could go up 1 and over 2, put a point there, draw my line, or go down 1 and to the left 2, okay? For the second one here, I can go to -5, and then I could go down 3 and over 2, or I could have gone up 3 and over 2, draw my line, and Actually, it looks like on the orange one, maybe I used intercept method because I have the two intercepts or not. Yeah, I don't know. Either way, it doesn't really make a difference. It's just give me the same line. And I get my point of intersection. What's that point right there? Hopefully you said it was -4, 1. And if you plug them in, I'm not going to take the time to do that. Oh, I might as well. What's half of -4? -2. -2 plus 3 is 1. What will we plug in for y? 1. Oh, great. What is -3/2 times -4? Two negatives cancel. The 2 and the 4 cancel, become a 1 and a 2. So we end up getting 3 times 2 is 6, minus 5 is 1. What do we plug in for y? 1. Hey, it checks. It's a solution to the system. All right. And these are solving systems great for word problems and real life situations that are more complex than what we were doing in our last sections. Okay. So a roofing contractor buys 30 bundles of shingles. You know what shingles are, right? They're the things that are on roofs that have they look like, usually they're like wood, or sometimes we have actually shingles on our roof. They're clay though. Okay, and 4 rolls of roofing paper. So usually on a roof, you lay out roofing paper and then you put the shingles on top. It's like the roofing paper provides kind of an extra, hopefully waterproof barrier. And then the shingles also prevent the water from getting in. Okay, so anyway, contractor buys 30 bundles of shingles and 4 rolls of roofing paper for $1,040. Okay, in a second purchase at the same prices. Okay, we don't know what the prices are. I think we're gonna have to find that. Same prices, the contractor buys 8 bundles of shingles for $256. Did he buy in the second purchase? Did he buy roofing paper? No, that's okay. It's okay. We need to find the price per bundle of shingles and the price per roll of roofing paper. Okay. And I love how they break this down. So let's take a look. Let's kind of write these 2 equations that make up our system in words first. So wouldn't that be 30, right? Because that's the number of bundles of shingles times the unknown price per bundle of shingles plus 4 rolls per the price of rolls of roofing paper has to equal our total cost of $1,040. Okay. And for the second one, you could have just put 8 times the price per bundle plus 0 times the price per roll, but you really didn't need to have that. But either way, it equals 256. Okay, now in this particular case, it really doesn't matter which you assign to X and Y. If you want to do it like I did, I assigned X to be the price, the number of dollars per bundle, okay, of shingles. And then therefore Y is the other unknown, which is the price per roll of roofing paper. Okay, so think about it. All we have to do is now plug in X for the price per bundles into our word equations and Y in for price per roll, or if you didn't do it on this one, that's okay. And we can have our system. So what would the equations be? Hopefully you came up with 30X plus 4Y equals 1,040 and 8X equals 256, or 8X plus 0Y equals 256. There's no real reason to have that. Okay, and now what are we gonna do? Now we're gonna go and graph them, okay? So watch what I do on this first one. First, it looks like I'm gonna put it into slope-intercept form. So first I subtracted 30 from both sides, and then I divided by 4, okay? And this is my equation. So now I need to go and graph that, right? And this one, what kind of line is 8X equals 256? Or when I divide by 8, get X equals 32. If we put X equals 32, what kind of line is that? I hope you're saying vertical. You all should know that at this point, that means that it's a vertical line, right? It's every point that has the same X coordinate of 32. So go and graph those. Hopefully you came up with 2 lines that look like this. X equals 32 would be vertical with an X intercept down here of 32, 0. And to graph the negative 7.5X plus 260, go to your Y, your intercept of 260. And then, I know it's not super easy to graph negative 7.5, especially when each box is worth 4. But if I was going to go down 7.5 for every 1 I go to the right, wouldn't that mean to go over 4 boxes that I would go over 4 times negative 7.5? Or if I wanted to go over to 8 boxes, I'd go 8 times negative 7.5. And that's how much I would go down. So 8 times negative 7.5 is, what is that? That's like 60. So we would go down 60. So instead of being at 260, we would be at 200, which is exactly what this one represents. So then once I have 2, I can draw in my line. Okay, where do they intersect? It looks like they intersect, well, definitely at 32, comma, and it looks like it's about halfway there, which would be, if it's 40 up to there, that would be 20. So $32 per bundle and $20 per roll. How would you check it? Hopefully you just said, well, I would figure out the cost for all the rolls and the cost for all the bundles. Easy to multiply that, right? So 32 times what? 32 times 8 would be what? Right? Because if we're going to figure this out, what's 32 times 8? 256. So that makes this one true, right? Okay. What if I plug in 32 times 30? Isn't that the same as 30 times 30 plus 2 times 30? 30 times 30 is 900. 2 times 30 is 60. So that would be 960. And then 4 times 20 is 80. Okay. If you add 80 and 960 together, you get 1040. So it checks. Okay. And notice that's the only solution because that's the only place where these two intersect. Okay. Here's one that's a little bit closer to home. You have a total of 18 math and science exercises for homework. You have 6 more math exercises than science exercises. How many exercises do you have in each subject? By the way, I know that this is actually very easy for you to figure out by guessing and checking. You may know the answer already, but let's practice setting up with an easy problem, setting it up and using a system and graphing it so that we can learn from it. Okay, so you can tell, just even though I've covered up the actual graphs, you can tell by the way I've labeled the axes, which you always must do, that I've done math problems to be on the x-axis and science to be the y. So x equals the number of math exercises, y is the number of science exercises. Okay, so what would your system be if you have a total of 18 math and science exercises? What equation could you write from that? Hopefully you're saying x plus y equals 18, okay? And then you have 6 more math and science. So are they balanced in the number? No, math's got 6 more, it's up here. Science is down here, it's 6 less, right? So how could we balance that out and make them equal? Well, we could either subtract 6 from x to be equal to y, or we could add 6 to y to make it equal to x. So I chose to add 6 to the smaller number. So this is kind of like the half Robin Hood that gives to the poor, right? Could have stole from the rich if I had done y equals x minus 6. Okay. I've decided in this particular case to use intercept method since it's pretty easy when I set x equal to 0 to figure out what y is and when y is equal to 0 to figure out what x is. So I have my 2 points and then I just connect the dots for that one. This one, I think I did the same thing. It wasn't that hard to figure out. If I set x or y equal to 0, then obviously x equals 6. And oh, it looks like I did it maybe a little differently. I picked another number, I guess, to plug in for y. I plugged in 12 and I got x is 18. So then connect the dots. So you have your 2 graphs and look where they intersect. Hopefully you got something where they intersect at about 12, 6. So that would be what? 12 math problems, 6 science problems. Okay. And of course, that's how it should be. You got to practice your math, right? Science problems usually take a little longer too. And by the way, does that make sense? Is 12 double 6? Or is 12 6 more than 6? Yeah. Does 12 plus 6 add up to 18? Sure does. Okay, cool. All right, now for some fun. I want you to write a brief script And be creative, have fun with this. Write a brief script, like so it's for a movie or something or a play. Um, for a phone conversation with a friend who was not in class today, explain what a system of linear equations is and how you solve a system of linear equations by graphing, okay? So go ahead and do that. Write out your script. Be interested to see what you come up with. Okay, and pause the video and do that. And then now for the fun. Here's mine. Two people are involved in this. Fergus, and Petunia. Okay, so here we go. Hi, Petunia. I missed you in class today. I hope your warts removal surgery went well. Thanks, Fergie. It went great. I see we learned what a system of linear equations is today in Mr. Kalen's awesome math class. Boy, that is one caring teacher we have. Can you tell me what this system thingy is and how to solve it by graphing? Sure, sweet Petunia. Mr. Kalen did a fantastic job of explaining it today, so this will be easy. A system of linear equations is just two or more linear equations that have the same variable or variables. For example, f plus p equals 2, and f plus 1000p equals 200 would be a system because each of the equations has an f and a p in it, like Fergus and Petunia. Wow, that's so understandable. Fergie, you are really starting to grow on me. To solve by the graphing method, all you have to do is graph both equations on the same graph and see where the lines cross. Make sure to graph really carefully, kind of like how you brush your dreamy hair, Petunia. The point where the lines cross is on both lines, which means the ordered pair for that point is a solution to both equations. Thus, it is a solution to the system. Not bad at all. Thanks so much. Maybe we could talk about how to solve a system by substitution over a frozen yogurt with 2 spoons after Mr. Kalen teaches us this after Thanksgiving. Oh, that would be swell. And in the end, it turned out F plus P equaled happily ever after. The end. All right. I hope you enjoyed that little story. Wasn't that wonderful? And now you're ready to tackle the exercises we have set up for you on 5.1. All right. Have a great time with that. And I promise you, you're going to love the next two methods for solving systems. Much faster, much more enjoyable to do, much more accurate than graphing, but we got to learn it and do it. All right. See ya.